look up to make you not feel sleepy, right? Okay. 张克利 ，yeah， 张克利，yeah， and 沈阳，yeah， 沈阳在 ，and 陈大卫在，郑佳在 ，and 孙初江在，陈文琪
在这里，
在 ，OK，and 王泽文，and 罗文 here， 莫友 here， and 王静雅 ，yeah， 王静雅 ，and 李子乔 ，yeah， 子乔 here，yeah， okay， now feel better, right? Okay, let's continue. And here we know we can use the stress concentration to explain why always the crack developed from micro crack, yeah, and the reason, okay, and the micro crack always be there, exist in the concrete because of these two materials. They are different, yeah, they are different, yeah. And here we just analyze the concrete in the engineer landscape because they are meters, right? Meters. So in our class, yeah, okay. In our class, we always regard the concrete as a uniform material. But if in the chemical or the civil engineering material, the teachers, they will explain, the concrete is a composite material, because they view the concrete in the millimeter scale. Okay, there is a different. But in our class, we always think the concrete in the engineer landscape. Yeah, that's why we always think it's a uniform material. We will do not care about aggregate, about cementation, and what else. We just think concrete. Oh, it's a uniform material. Yeah. Okay. Here's that's a way that we think, how we think that. Okay. And here, we come to the mechanical property of concrete, the second section of the strengths of the concrete. Yeah, someone may not know the strengths of the concrete, but here we will academically to learn for concrete what the concrete strengths. And here, there's three important strengths about concrete. I hope maybe students can write down for the cubic compressive strength and the prism compressive strength and the one and the tensile strength. These three strengths we will repeat to see it again and again about concrete, right? Concrete. Here is three. And I can see at first here for cubic compressive strength, we always use this strength to classify the concrete grade. Yeah, grade. If we see C30, C40, this 30, they represent grade of concrete. But also the meaning is this concrete, the cubic compressive strength is 30. Okay? There is a relationship about grade, meaning what he corresponding to is the cubic compressive strength. For prism compressive strength, this is the concrete strength for design. Yeah, if sometimes, if future we will see, we use C30, concrete. For we will use 22, maybe 22.29. This strength in the design. Do not directly use the 30. Okay? For here is the prism compressive strength. We use this stress in the structure design. And the cubic compressive strength just a grid, the grid to classify concrete. And for the value now, some students may find the prism compressive strength is a little smaller, right? Little smaller than the cubic compressive strength. And here's later I will see the reason. But now for you must remember what the meaning and what it's used. What's the meaning of this cubic prism? And for tensile strength, we know for concrete they are weak in the tensile. The tensile strength here just let you know how we to carry the test, carry the experiment to measure a material to get the tensile strength. Okay, this is three. It's three. And here, for we to get how to get the strength. Of course, we should do the test. But before, we know the strength will relate to the resistance. Resistance, right? Resistance. And how many factors that will affect resistance? We mentioned the structure's size, right? Structure size, and the computer method, a calculation method, and the different material, right? These three things will affect the material, the resistance. And so at here, how we get strength, we need to give a standard. Give the standard, standard. So for the standard specimen, look at here. This is the cubic, right? Cubic. The size of the length is 150 millimeters. That means in everywhere, in China or in America, they will use the cubic. Not America, just Europe and China. They will use the cubic, the size of the concrete. This size is the standard. We do not change it, okay? And to use this specimen, the standard specimen, and of course the size is the standard. The curing conditions is at 200 degrees, and the humidity should be larger than 90%. The day is 28. This the loading rate for high strength concrete no less than 95%. Okay, 95% is the curve we get here. 95%. To use this specimen under the machine, under the load, to get how it can provide resistance, provides the resistance strength. This value, and then do the statistic analysis. Then we obtain the cubic. Use this stress as the strength. to represent the concrete, the degree of concrete strength here. Okay, and here's the distance is 1.645. Here's use a video. This is the machine. We use the specimen, standard specimen under this machine to get the strength, compressive strength.
Hello viewers. One of the important properties of concrete in its hardened state is its compressive strength. Compressive strength of concrete is important because other strengths such as flexion, bond, and resistance to abrasion improve with increase in its compressive strength. The compressive strength of concrete depends upon the proportion of ingredients used in concrete. It is therefore important to find the strength of concrete using different proportions of ingredients.
Yes, because for we know there's a different proportions about water, cement, and sand, gravel, right? This is the ingredient, different proportion and different ingredients here. They will have a different strength of the concrete, right? Different concrete, but we need a standard strength that's used in structural design, and to divide that. So we may develop a proportion of ingredients, yeah, and to write down and to remember. We in this place we use these proportions. We can make this standard strength of the concrete, and use them through another ways. We also use this proportion, this ingredients, and we can to make the same strength the cubic, right? So this proportion, this ingredient that people do lots of tests, do lots of experiment. They know here in order to get different strengths concrete.
To meet the structural requirements. In this video program, we shall demonstrate the procedure for casting and testing of cement concrete cubes. The equipment and accessories required for making the concrete cubes and testing them for their compressive strength are cube molds of 100 mm or 150 mm size with IS mark.
Here,
We are
100,
using
but always
150
be
mm cube molds in
150
this case.
millimeter size for the cube.
Electronic weighing balance, GI sheet for making concrete, vibrating needle, compression testing machine of capacity 100 tons, 200 tons or 300 tons depending upon the weight of concrete of which cubes are to be cast, and the observation sheet to record the readings.
Yeah, they just get the different proportion cement.
For casting the cement concrete cubes, measure the dry proportions of ingredients as per the design requirement. For example, in this case, the proportions used for casting cubes are 1:1.5:3
Here,
as
give
per
up the
Indian Standard
proportion.
Code 456.
This proportion may get
2000.
one strength, one for each.
The dry ingredients are then thoroughly mixed so as to obtain a uniform mixture.
Uniform mixture.
The proportion of different ingredients taken should be sufficient enough to cast 3 molds. Take the desired quantity of water. Add this water to the mixture.
Pour the water first and then mixture. So here just to show the process how we to get the standard specimen. But different people may use different ingredients.
Mix the ingredients thoroughly so as to obtain concrete with uniform texture. Using the scoop, fill the concrete into the mold.
This is the mold. Standard mold 150 millimeters. Cubic. Cube. Use the vibration needles to make the uniform.
It is then compacted by means of needle vibrator, ensuring thorough compaction of concrete.
And when we add here, when we add the waters in here, the hydration will happen, right? Happen. And the hydration we know, in some other video, we know the humidity, the temperature, they will affect the hydration. So we use a standard. It will give us in the PPT, it give us only at this range, the humidity, at this temperature, that specimen had the meaning to test. If the temperature is really high, that's the no meaning to know at this ingredient the strength.
After the top layer has been compacted, the surface of the concrete shall be finished level with the top of the mold using a toggle. It is tapped well till the cement slurry comes to the top to give it a well finished appearance. After some time, the molds are covered with wet gunny bag and left undisturbed for 24 hours at a temperature of 27 plus minus 2 degrees Celsius at 90%
Yeah, they give us the standard the temperature.
After 24 hours, the specimens are removed from the mold.
Move the mold and get the specimen, standard specimens here. Look at here. And look at here, we see there's smooth, right? Smooth. But in the micro view, we know there the micro cracks already exist in between the dissemination and the aggregate. So
they are then taken to be kept submerged in clean, fresh water at a temperature of 27 plus minus 2 degrees Celsius.
Degrees Celsius.
The specimens are kept in the water either for 7 days or 28 days. Water in which specimen is submerged should be renewed after every 7 days.
Here, I explained the 7 days they use also okay, but because people establish a formula, we can know the 7 days stress, then to drive the 28 days stress. The formula. So it's okay, but if you get 7 days, we need to substitute the value into the formula and then get 28 days stress. So because there are a lot of people to do this part of research, they have a lot of formulas. So choose which one may be hard. But if you had you just want to save the time, you can use the 7 days and again derive the 28 days. But if you have enough time, just in the 28 days, get the standard the values.
Specimens, when received dry, should be kept in water for 24 hours before they are taken for testing.
Some details, the process.
The cubes are taken out of the tank just half an hour prior to the test. The specimen to be tested for compressive strength should be in surface dry condition.
Surface dry.
This is the compression testing machine where the concrete cubes are tested.
The compression
The capacity of
testing
this machine is
you
300
may
tons.
see in our school.
For testing the compressive strength of cube, it is centrally placed in the
They
loading
put
unit.
the specimen on
The
the
load
machine.
shall be applied to opposite sides of cube as cast. The axis of the specimen shall be carefully aligned with the center of thrust of the spherically
The
stated
center
stator.
should be the middle point, the center, and then they give the load, give the pressure, the pressure increase.
Now, slowly apply load at the rate of
The rate, the
140
load,
kg
the machine
per
load,
centimeter
if
square
applied
per
to the
minute
specimen,
till the cube
the
breaks.
speed should not be so quickly, it should be slowly. They have the rate limit, and then because of the constant stress concentration, always develop from the micro cracks.
The maximum load at which the specimen breaks is taken as a compressive load.
For they reach values this approach. This values to not increase. So that means the job means the concrete
It is
cannot
90
resist
tons
the
in
load.
this case, recorded in the observation sheet.
Yeah, he used a table, used a paper to record the values. And because this is just a one specimen, for him, he should have lots of sample specimen and use the machine to do the test and collect the data and then draw the distribution curve.
The compressive strength of the specimen shall be calculated by dividing the maximum compressive load taken by the specimen by its cross-sectional area. Compressive strength shall be equal to compressive load divided by the cross-sectional area of the specimen. The cross-sectional area of 15 centimeter cube is 15 multiplied by 15 centimeter, which is equal to 225 centimeters square. Since the compressive load is 90 tons, the compressive strength of the cube shall be equal to 90 multiplied by 1000 divided by 225, which comes out to be 400 kg per centimeter square. Average of 3 readings shall be taken as a representative of the batch. In the present video program, you have seen the apparatus and the experimental procedure for casting the cubes, curing of cubes, and determining the compressive strength of concrete cubes. Since compressive strength is the most important property of concrete, it is therefore necessary that utmost care must be exercised in measuring the compressive load. As per Indian Standard Code 516, the individual variation in compressive load should not be more than plus minus 15% of the average value. If the variation is more, repeat tests for the same concrete must be made. I hope after having viewed this video program, you shall be able to perform this experiment in your laboratory. Thank you.
Yeah, from the video, I think students may now know carefully about one. Here's the standard, right? Standard process of to get the strength. A different country may have a little different, but in a country, the curing condition, the humidity should be the same. That has the discussion meaning, right? If different place use different the conditions, that means just the same ingredient they used to get the concrete strength is different. Okay. And for the character strength, this is also the curve. How to get these values? We use the average mean minus 1.645 standard deviation with the formula, right? We should make sure the 95% the strength what we can get. And look at here, the cubic we used and the specimen in the test. The failure mode would be like this. Because here it had a friction. Because we put the specimen on the machine, the surface of the specimen will touch the machine. And if we use some oil on the surface of the machine and surface of the concrete, the tube concrete, the failure mode will be different. Okay. Can you imagine the machine, the surface, this one touch the machine of its friction, it will affect the specimen. And here, this surface, this part will be stronger than the middle part. So the crack. Here's what I friction effect, it causes the cubic compressive strength larger than the prism compressive strength. The meaning is the friction effect. The cubic compressive stress can't reflect actual stress straight because of the standard specimen. They will affect it. They are affected by the friction. And in the videos, you may find the guys they mentioned another size is 100 multiplied 100 and 200 and 200. Yeah, they had the relation, the conversion coefficient here. If we use the 200 length, the cubic, to get the compressive strength, how to transfer this strength in the standard specimen, we should multiply 1.05. Okay? And if we use only the 100, the cubic specimen, we should multiply 0.95. Why? Here's because this is the large. This is the small, right? Small size. They affected by friction very strong. So the compressive is measured. This values be large than this size. So here for the compressive strength, we should multiply a coefficient. It's smaller than 1, right? Smaller than 1. Yeah, because the size of the 100 cubic is smaller, right? Smaller. That means it affected more by friction. That means the compression strength what we test, the value will be larger than the standard one. So here we multiply the coefficient, it's smaller than 1. Yeah, and for the 200, because the size is larger than the standard specimen, that means this larger specimen, they affected a little by the friction. Yeah, here may be hard to understand, but you can imagine, right? You can imagine for smaller string, right? String, there is like this string. Because here we measure under this load, right? Under the load is the same, right? Load is the same. Because of the friction lead here, they cause some area. This area, this deviation. This deviation to divide the totally the length L, right? It's smaller than the same deviation divided L. This L is smaller. This is the larger. So this value, of course, be larger, right? Yeah, the deviation is the same because this deviation just like the friction, right? The friction effect. The friction effect divide the larger size. That means the unit of the part they affect smaller these deviations. But for the small specimen, that means the same deviations they will cause the large affection. Yeah, that's the meaning of the convergence coefficient counts. Yeah, but and in America, Japan, Canada, they do not use the cubic. They use the cylinder standard specimen. Right? Yeah, they also people to establish the transfer formulas. But it doesn't matter. For here, what I introduced here, that's a test process for we to get standard the compressive strength based on the cubic space. And because of the some place they use the larger size and smaller size, and there's a formula or there's a coefficient we need to use. Okay. And look at here, the compressive strength should no less than 95%. And there is an important concept to be if the concrete compressive strength larger than the 50, we name it high strength concrete. High strength concrete. Less than the 50, which is the normal strength concrete. Yeah. There's so many different grades because these different grades represent there's a different proportion and the ingredients. Different proportion of the ingredients, like water, like the sand, aggregates, the cement, and in the video they use one, and 1 divided 2 and 1. Like their proportion group different gets a different rate, different concrete rate. Yeah, and the topic here. Yeah, I think enough of today's class. And you can, if students have some problems, they can see. I will try my best to answer it. And if you're not get the point of this class, I just see it. Yeah, for you the mode, right? The mode is standard the size. Yeah, the friction influence will become greater when the size becomes smaller. Size effect.
On the friction,
Yeah.
the friction is it on the surface of the cubic cube or inside?
You mean inside in the cubic?
Yeah, which friction are you considering? The one on the surface or inside?
Yeah, the surface, because the machine touch the specimen, right? The compression tester machine, there is a plate. We put the cubic on the plate, so they touch together. Yeah, they touch together, and then give the force to the specimen. Yeah, and this on the surface. Of course, the friction of the concrete his own exists inside. They have the friction that's about the concrete his own. But for here, why the failure mode looks like this? Like here, he always keep can contain can like the rectangulars. That means because this surface touch the machine. Touch the machine, they can enhance or strengthen this area of the concrete strength. So the failure, the concrete peel out like this in the middles because there's no other things to support in the middle part. So at here the failure they peel out from the concrete. Yeah, okay. Okay, today class is over.